Hi there, and welcome to my grade 12th class. And today we're starting the sections on logarithms. This is the advanced functions class. Alright, now logarithms. Logarithms and exponential occur naturally in many branches of science. They're actually very important in solving problems related to growth and decay. The growth and decay may be that of a plant or population, a crystalline structure, or money in the bank. Therefore, we need to have some understanding of the way in which logs and exponentials work. Now, how are logs and exponentials related? That's the first thing. So just as multiplication and division are related, as are logs and exponentials. So for example, if I did 6 times 4, we know that's 24. What if I did 6 times 4 divided by 4? What do I get? Well, as you all know, if you times by 4 and divide by 4, well, they just kind of cancel out and give you 1, so you only get 6. 6 times 1, 6. So just in the same way, logs and exponents work. Now, one more thing. If I do 6 times 4 divided by 9, do these cancel out? Well, no, because the base number is different. So basically, the base number has to be the same, and it has to be the opposite function, or rather operation, and that's the only way that they will cancel out and result in give you a 1. Alright, so now back to logs and exponentials. So the definition of a logarithm. If x and b are positive numbers and b cannot be 1, then the logarithm of x to the base b is the power to which b must be raised to equal x. It is written log base b x. In algebraic terms, this means that if y is equal to log base b x, then x is equal to the b to the power of y. Now, this may be difficult for some of you to understand. So let's take an easy example. So let's say if I want to take log base 3 9 is equal to x. So what I can do here is I can make an exponent on both sides. Basically, well, we know the base of the logarithm is 3. So then the base for the exponent should also be 3 if we expect to cancel out anything. So we raise the equation to the power with base 3. Now, as I said, since just like multiplication and division, exponents and logarithms are opposite operations. So therefore, they will cancel out to give you 1. So 9 times 1 is just 9, and this is still 3 to the x. Now we know 9 is actually 3 squared, 3 to the x, and we know then that x is equal to 2. I'm sure that most of you follow that. So basically back to our generic terms. So what they did here was basically, what's the base here? Base of the logarithm. Well, that's b. So then we take this whole equation and we raise it into the exponent with the base b. So basically, now we have b to the y and b to the log bx. Now, as I said, the b to the power log b is actually, since they're both opposite operations, they will cancel out. So that's why you only have x. So on this side, you only have x. On this side, you have b to the y. So hopefully that clarified a little bit on how they got this function. Alright. Now, the one last thing. If the formula is written like this, y equals log base bx, it said it's written to be in the logarithmic form, and if the formula is written x is equal to b to the power of y, it's said to be written in the exponential form. But just so you know, these two things are equivalent statements, meaning they're the exact same thing. Alright, so now we have an example. Example 1. Log base 4x is equal to 2. Well, the important thing to remember is always the base. So the base of log is 4. So if you want to get rid of this log term, what we do is we raise the whole equation to the power with base 4. So 4 becomes here, 4 becomes here. So that's 4 to the power of 2 and 4 to the power of log base 4x. So since they're the same bases and they're opposite operations, they will become 1. So x times 1 is just x, as you see here. And this side, the right hand side, is 4 squared, which you can see here. And 4 squared is actually just 16. So that was a simple example. Now we have 25 is equal to 5 squared. Now, just as you can raise the equation to a power with one base, you can also take the log of both sides. Now, if you were to take the log of 25 is equal to 5 squared, log base 5 is equal to 25 is equal to okay, so now here you see the log base 5, 25. That's simple. Now why did I choose base 5? Well, in this original equation, do you see an exponent? Well, yes you do, the 2. The 2 is the exponent. Well, what's the base of that exponent? Well, it's 5. So therefore, if we want the operation to be opposite of each other, the bases have to be the same. So that's why I chose the log base 5. Now if I did log base 5, it's 25. So that's just written like that, as you can see here. Now where did this 2 come from? Now remember, exponentials and logarithms are opposite functions. Therefore, if I wrote the log, if I take the log of an exponent, well, these just cancel out, because remember, this is log base 5, and this is 5 to the power of 2. So this actually just cancels out, and you get 2. So that's where the 2 comes from. So that's not too difficult, hopefully. Now, for our third example, we have log base 9, x is equal to 1/2. Well, like I said, key important thing is the base. So we know the base is 9. So we have to raise both sides of the equation with the base 9. It's 9 to the power of log 9x and 9 to the power of 1/2. So, well, 9 to the power of log 9 is, well, just, cancels out. So you get x, and 9 to the 1/2, well, 9 to the 1/2 is actually just root 9, and then x is equal to 3. And that concludes my tutorial on Intro to Logarithms. Thank you, and hopefully you enjoyed it.